Okay, so we're gonna be talking about all of the lore of the Jony A solar system. Now, of course, to start, I will just be mostly calling it the Jony A system. Or Jony Star. Basically, I'm removing the A. So, yeah, that's what I'm gonna be doing. Now, if you know my latest video, you would have saw that the little star was actually blue. Now, of course, it is blue. It's just that, well, it gets blue not in the same way that O-type stars are blue. It gets it in a different way, chemically. Now, of course, let's start off with how it even got the scratch, which is extremely large when you realize it's almost 6 billion kilometers in length, which is extremely large. And it happened due to a crash. So basically what happened was a large gas cloud made of, well, we'll talk about later. And basically these clumps of gas formed into two major bodies that we will now call, one of them we will call the Jony A star. Now the other one I did not give a name. So I'm gonna just call it nothing. I'm not gonna call it anything. But really though. Anyway, let's actually move on to the topic. Now, as soon as it crashed into it, it literally scraped off a good chunk of the atmosphere. And then it scraped off even more of it until there was almost no atmosphere left of where the scratch was. Now, of course, the scratch formed because of that. Now, the reason why there were little blue stars all around, at least, because this is not actually real, it is fake. So, everything that I'm going to tell you afterwards is going to be imaginary, just to know, and everything before. So, moving on, I was about to talk about, the reason why all that stuff happened. Well, it happened because of their two massive black holes ended up crashing into each other and causing a huge amount of disasters. A lot of disasters that I will not talk about. Basically what happened is that a lot of it just got splattered all over the place. A lot of matter and gas just got blown all over the place. Like basically a kid playing with cake. And that's basically what happened. And all that gas just became stars and stuff. That was one of the reasons why that happened. Now, of course, moving on to what the gas is even made of. Well, it's mostly made of water, hydrogen, nitrogen, helium, and oxygen. Mostly that kind of stuff. And also a pinch of carbon. This is also what the star is made of, but it's just that the area where the scratch is, which is actually a peek into the inner layers, well, the first layer is not as blue as you might think. It's barely even blue at all. It's because there is not a lot of water and hydrogen and nitrogen and oxygen to actually make it blue. Unlike the rest of it, which is a whole lot more blue. Now, of course, moving on to a different area. What? Wait a minute, what was I thinking of again? Oh. How big is it? Yeah. Some other random stuff. How big is it? And some other random stuff. So basically, it's around 30 astronomical units, or the distance from the sun to the Earth. Around 144 million kilometers, which is very, very big. Now, of course, that is not that big when you realize 70 of those can fit in its diameter, or around 10.8 billion kilometers in diameter, which now makes that look small. Now, of course, if you actually put it in the same spot where the sun is, it would not just swallow all the planets, But if you added its mass, everything would get swallowed indefinitely. All the Oort cloud. Around 99.99% of the Oort cloud would be eaten. And the tiny percent that managed it, it would just orbit in really kooky ways. So yeah, that's what would basically happen. But let's say somehow we got 78 astronomical units away from it. I mean, half of that distance actually, or 38. Or like around 39 astronomical units away. Well, we would somehow be habitable. Don't ask me how that works. But then it would be hotter than that little planet, which I'm not getting to right now. That's for later. Okay, but actually, it is mostly that. That's really it. Its size. Now, of course, if you tried actually walking, which is around 2 miles per hour, or I'm just reimagining as 4 kilometers an hour. Oh yeah, that would take you. That means you would be traveling almost 100 kilometers a day, which means that you would have to do that so seldomly much. Oh, okay, so you would travel around 1 moon in a year. And you would be traveling 1 Earth every 4 years. You would be traveling 1 every sun once every around 420 years. And that would take 40,000 years for it to go through 1 astronomical unit. And you would have to do that 70 times. And I'm not doing the math for that last one, though. You know, I did the math for the other portion. But anyway, that will take a really, really long time. Definitely somewhere in the hundreds of thousands, maybe even early millions of years. Which is a lot, especially because our common ancestors were chimpanzees and us was only around 6 million years ago. So yeah. And oh wait, I think I got it. It would be around 28 million years. Yeah, that's a lot of years. Just so that you get from one point to the other point of that. Now, of course, here is some weird stuff about it, including the black hole's axis, which is kind of weird. When it was like bonked, yeah, it made a lot of energy and caused a big supernova. And yeah, it also caused it to get yonked off. Or should I say bonked. So hard that it literally just caused it to go in the wrong tilt. Which is why its accretion disk, which is basically just a bunch of spinning gas in a ball of spinning gas, to be almost exactly where the axis is, which is only around 12 degrees off. Which is kind of weird and confusing at the same time. But hey, that's nice to be in the lore. Now, of course, moving on again, and basically, yeah, that's what happened. Now, of course, moving on to something else. That will be, what's on my lore today? Oh yeah, how it makes energy. Because here's something about it. It makes a whole lot of energy. I'm not telling it now, but I'll tell it later. But it's just that here's something that I will tell you. It has a luminosity of 10 million suns. Okay, that's quite a lot, but how does it even get its fusion? If its own temperature can't even... Oh yeah, I'll talk about the temperature, yeah. I forgot about that. Yeah, so its temperature isn't even that hot. They're around 200 degrees Fahrenheit at like the atmosphere. and it gradually gets hotter all the way up to 1200 degrees. Here's an actual little prediction map for the entire thing. Okay, that's enough. Now, of course, moving on to the actual energy. So you might have saw that, and you realize, how could it make that much energy with so little heat? Simply, it just makes it something else. Now, I explain it kind of in depthly. Basically, what happens is that the oxygen, hydrogen, and other molecules just get bonked and bonked and bonked so hard that they actually make new molecules. Random stuff that barely lasts anything and makes a huge amount of energy when it just breaks apart. Then boom, boom, boom. This keeps happening many times, and very, very, very quickly. So yeah, that's how it gets all of its energy, or at least a very high majority of it, because the other small majority of it is just the black hole heating its accretion disk, which I did not count in the temperature map.